Good afternoon. My name is Bill McKenzie. I'm an IT architect, software engineer at Chevron Corporation. And this afternoon, I want to talk to you a little bit about the journey that Chevron's going through in trying to do enterprise-wide infrastructure as code. And this is something that's been going on for a little while. We're sort of just in the middle of a program to implement it, so you're not seeing sort of a finished product, but it's a little bit about the journey, why we're doing it, what we expect to get from it, and maybe you might learn a little bit about how you might do it in your organization. Covered that already. There we go. So a little bit about Chevron. Of course, I think the name's pretty well known. You all know us from the little plastic cars and the gas station on the corners. But Chevron, of course, is one of the largest oil companies in the United States. We're one of a dying breed of what's called a fully integrated, which means that we're a company that does every part of the oil and gas supply chain, right from exploration and finding out where the oil is, all the way up to putting it in your tank and the extra products and stuff like that. What this means is that, we look like really a bunch of different businesses, right? Because these, although they're connected, the logistics problems and the way you run your business is very different in these different parts of the supply chain. And of course, we do this all around the world. So this leads to a very complex IT environment. And for us, that means that we have operations on pretty much every continent. We have, in addition to the dots that you see all on the map, what you don't see are the floating dots. So that's the tankers and the drill ships that are actually out in the water all the time, each of which is sort of a data center in its own sense and carries multiple applications and quite a bit of processing power on them. So it leads to a highly diversified environment, and one where over the years, as I'm sure with many of your companies, we've built up an incredible amount of sort of infrastructure debt. We've typically worked in the environment of very clear separation between operations and the applications people. So it's been mostly just sort of, I need a server, give me a server. Operations provides servers, and the result is a sprawling amount of infrastructure. Sorry for walking back and forth here. I get the clickers, the batteries may be dead. But so the thing that's driving the change for us right now, this was a study that we did about a year and a half ago, and it was an interesting problem that we had where we were trying to figure out how to optimize some of our data center assets. And one of the first things we had to do is sit down and say, well, how much data center we're going to need in the future. And this slide, which is something we call the North Star, this is sort of part plan and part prediction, sort of trying to say where these different categories of hosting facilities are going to go. And this big black thing here is what we call legacy. That's sort of the way we do things today. These ones here represent the various bands of what we call the different clouds that we see we'll be using over the next 10 years. Starting with SaaS, this is where we're just basically using SaaS to run applications on other people's clouds. Public cloud being things like Azure, and then private we sort of split between edge and central in terms of where we think the private cloud will be. And so what this slide told us was that we were going to have to move a lot of stuff very quickly from their current environments to other environments, and B, we were going to have what you would call a hybrid environment, so that if you just look even 5 years out from now, we're actually going to have applications divided across a very wide kind of spectrum of infrastructure environments, which told us that we needed a way of abstracting away how we build and deploy applications from where those applications are actually going to go. So I don't know how you do architecture in your company, but at Chevron, we go to a Gartner conference once a year. We make a list of all the big words that are going on that year, and we come back from the conference and we ask our management for a bunch of money to go implement whatever those words are. So that's a joke, guys. Come on. But these are some of the terms that are floating around, and because there's not one term that defines what we're doing, but these are the things, the sort of directions we're trying to go, and the things that we think will make us more agile and more portable with our application environments in the future. Infrastructure as code is simply this concept that instead of, making a service ticket and saying, give me a server, and then the server exists and goes maybe into a bunch of databases somewhere to try and track it, every time you want something, it's written down somewhere as code. And that code simply, whether it's a single server or whether it's a large cluster supported by a storage account and a load balancer and whatever, you have some definition of the resources that this application is going to consume, and those things are controlled and managed in source code. And so this is the getter, it didn't happen, is this is something that programmers sort of take for granted, that when you write code, you put it in a source code repository, you do pull requests, and you version it and all this. For our infrastructure community, this was something that was pretty new, was that everything you do on the environment actually starts as code. You can trace it, you can difference it between different versions, you can go back to old versions and all of those kinds of things. That brings a lot of power to your ability to understand what your infrastructure looks like. Automation obviously is a huge thing right now. People costs, it's interesting is if you go back, I'm an old guy and I started at the command line, and there was this sort of revolution where all the things went to graphical interfaces, and we've become so consumed with these graphical interfaces that we spend all our time pushing buttons, but we don't have any automation that actually says, if I just did these 15 things, I clicked all these buttons, and then 5 days later somebody came in and clicked 4 more buttons, and then I added some memory, then I did something else. There's actually no audit trail or no picture of saying what happened to this infrastructure in the last 3 months. Automation gives you this ability, combined with the as code, to actually recreate from scratch your infrastructure conditions exactly the way they exist today. DSC, desired state configuration, this is another important part of it. When we say as code, we don't mean as code that says do this, then do this, then do this. We say code that says it looks like this, make it so. So it's sort of the Captain Kirk way of defining what your infrastructure looks like. Instead of saying how to create it, you say what you want it to look like when it's done. Then when you run this in the automation tool, it knows whether it needs to add, remove, change, or bring things back up. All you're doing is saying my stack needs to look like this, make it look like that. The other big part of it is DevOps. DevOps to me is actually not something that's just done with developer, things that you develop in-house. This leads to something, a concept that I call application-centric infrastructure. So again, instead of just a bunch of servers, and if you're lucky, a CMDB somewhere has a tag that tells you what this server was meant to do the day it was provisioned, the concept of application-centric infrastructure is that along with this code definition of your infrastructure, you have everything required to run this application as a known bundle. And this little mini thing, and actually it's a very good fit for the concept in Azure of a resource group, right? So within this resource group goes everything life-cycled together that goes with an application. This makes it very easy to do things like decommission applications, because instead of figuring out what are all the wires that I have to cut and what might get broken when I bring things down, everything's neatly encapsulated and I can bring down an application all by itself. So So one of the things that we did.
Slides for you?
Sure, sure. So this is my Scott Guthrie. He's just going to help me out with. As we started going down this path, one of the things that we did was we defined this concept of an end-to-end pipeline that it took into account both PaaS-style applications and traditional IaaS-style applications, took into account in-house developed things and third-party application, off-the-shelf stuff, and it took into account services that were simply backbone things that are kind of an application in their own right. This pipeline basically defines all the components that it takes to get from this infrastructure as code definition to a running application. And so I'm not going to go into every box on this thing because the hook will come out and pull me off the stage before that happens. But, oh, super. All right, great. Thanks. All right, good. Thanks, Randy. Basically, we broke down all the steps into essentially a service or a component that would be needed to fulfill that in the automation pipeline. We went through, we made selections in terms of products. We created sort of service wrappers around the products to make them usable for Chevron employees in-house. And today I'm just going to talk about 2 or 3 of them that put together how we stand up infrastructure. So I'm going to, how much time have I got? What are we doing for time here? About halfway through? Yeah? Yeah, okay. Okay, so how many of you heard of a tool called Ansible? Yeah, yeah. So the decision that we made, first of all, we made a big partnership with Microsoft to choose Azure as our primary cloud provider. One of the things that we found difficult about Azure was that while ARM templates work sort of one at a time, they aren't really good for sort of enterprise kind of deployment and management. There's a lot of moving parts, and they were hard to manage, a lot of parameters to pass around. So we selected Ansible as a configuration management tool that also would be our infrastructure as code definition. And if we have enough time at the end, I'll show just a few of what those playbooks look like. But what we've taken is an approach of wrapping all of the Azure services in very simple playbooks that abstract the user away from a lot of the details that get gnarly about deploying an ARM and making it very simple for them to say, this is the stack that I need and this is how to build it. So some of the reasons we liked Ansible was it was all written in YAML, all text, very easy to see, very easy to read. It was driven by source code, and I don't mean just you check your code in. The actual product uses source code as a first-class citizen in composing playbooks and roles. So what that means is that if you're checking things in and moving them through a CI/CD pipeline up branches, you're automatically redeploying your infrastructure. References to roles, references to other playbooks are automatically resolved from source code control at runtime, which makes it a very, very simple system to maintain. ServiceNow is kind of it's the front end. So anytime you need permission to do something, anytime you're going to spend money, essentially, you have to start with ServiceNow. ServiceNow provisions out your resource group and the subscription that you're going to work in, and it makes sure that you've got all the correct tags that says who's going to get the bill, what opco you work for, who's the responsible party, how to contact you, and stuff like that. So it's the human side of it that kind of connects the infrastructure to the business. And finally, we're making a lot of use of Artifactory. This is a multi-interface binary repository, and so we're using it to store all of our raw operating system images, ISOs, NuGet packages, the binaries that come out of builds. So in the pipeline, everything gets pushed to Artifactory, and then the deployment stage is actually able to go there and pick it up and put it on the correct infrastructure. And then we're using both Jenkins and the build system in VSTS. We're primarily Jenkins. We're very interested in VSTS because it's such an integrated package with the Git repos and everything. But that's kind of the tool chain. I'm going to switch over. I'm going to have to stand behind the desk here because I don't have slides here. Let's hope this works. Does it work? No. Let's try this. There we are. I'm going to log in. So I talked about application-centric infrastructure. This is something we call an application manifest. It's really, you're looking at it as a document, but it's really a service document. So this is something you could get it at rest from a file, but it normally would come from a service that would provide it to you. So all that stuff that I was telling you about that you do in ServiceNow, this is all pre-populated for you. And when you go to do your deployment, your scripts don't need to know anything about this information. So all of this is supplied by the deployment system, meaning that you'll always go to the right resource group, you'll always be in the right subscription, and those things like what network VLAN or VNet you're going to go on to, and all of that kind of stuff. So a lot of the inputs that would be sort of very fragile and easy to break in automation code are supplied automatically. It also means that we can do things like for a certain subscription, we can change the default region at an enterprise level and start moving things into different regions for whatever reasons we might have for doing that. So each one of these represents, this manifest represents an application, in this case Jira. This is its service ID in our CMDB. This is sort of the thing that tells the enterprise where it sits in our application portfolio. This is the base URL that's used to compose the URL for the app. And then each one of these is an instance. So in this case, we have two environments, a test and a dev, and each one of them goes in a specific resource group. But all of this stuff is maintained in ServiceNow and is fed to the application system automatically. So then the other thing that we're doing is, I talked about wrapping. This is something called an Ansible role. This is the role for. I hope you guys are okay looking at this code. This is build, right? We can get techie. Okay, good. So this is an ARM template in JSON, which is just so much more civilized to begin with, right? You can actually read it, and there's no brackets. It's so much easier to comprehend. This little squiggle bracket stuff here, this is the Ansible speak for templating. So this is similar to kind of some of the template features that you'd have in ARM. But what we basically do is take a generic ARM template, we turn it to YAML, and then we parameterize it according to the things that Chevron always wants to apply to every definition of. So for instance, the tags on this thing come from this variable called CVX default tags. So early in the automation process, it read your manifest, figured out who you were, what your application was. It built a default set of tags. Now those tags will get applied to every single thing you do in this deployment. And you don't have to worry about tagging your artifacts. And then to the extent, and I don't know that there's many things on this one, to the extent that we want people to customize the resource, we would do something like say, yeah, so there's not much customization in this particular one, but the user has this role defaults to a capacity of 1. They can make that 2, 3, whatever in your service. This is an app service plan, right, for Azure PaaS. And then the other thing is the role not only has that template, but the role knows how to deploy that template. So there's a playbook in there that will basically gather up the template with all of its inputs. It'll parameterize it. And then again, all based on inputs that we pull from the ServiceNow manifest and the things like the client secret that come from the environment, all of that gets pushed to the cloud, and it deploys that thing. And this is something we're using for both, like I said, for both PaaS and for complex IaaS. So just to give you a bit of an idea, this is a playbook that this will deploy a SQL Server in an IaaS SQL Server. This will deploy SQL Server on an IaaS server in Ansible or in Azure. And this thing here, this Ansible role Azure IaaS, is the thing that actually provisions a VM. It's doing a small VM, and then we apply a couple of post roles, one of which installs SQL Server, and then we have some extra stuff here where we turn around and say, well, let's add some domain names. One of the reasons we decided to use Ansible is Ansible's not just a cloud tool. Ansible does everything from deploying into the cloud to installing software, to configuring software, to taking away drift and stuff like that. So it has this very rich set of tools for doing anything you want, both in the Windows and the Linux environment. So to take a look at a slightly more complicated one, that simply deploys a SQL Server and does nothing else. If I look at Artifactory, this is the playbook that actually deploys our Artifactory, if I can find that. And this kind of gives you an idea how you can sort of compose your infrastructure bit by bit. Everything always starts with something called main. And so every deployment looks in your source code repository for that application, looks for main, and runs it. So in this case, main says, well, first create and then provision. So this person's just decided to break things down into steps, right? So if you look at what create does, create actually breaks things down. Again, it says, create a load balancer, create my application server, create a storage account, and create my database. So this is actually, and then if we look into what those things do, and this is just really to break the code up to make it more readable. If we look at, say, the load balancer, it simply says, I want to apply this role, Azure Load Balancer. The name is going to be LB. I need port 443 TCP. And then I use, again, some templating to pick a name for this load balancer based on the application name. And notice none of this says where it's going. It's not saying what subscription is in. It's not saying any region or anything like that. All of that's handled in the background. But then after all these creations are done, so this creates the app servers. It actually creates three servers, because we're going to do a high availability thing here. Creates 3 servers, puts them on this load balance. They don't need additional storage because all the Artifactory storage is going in a storage account. When all this creation's done, we run this provision script, which does 2 things. It provisions the application and Postgres. So if you look at provision the app, you'll see something gets a little more specific here. What it actually does is, so here's where you really see the power of Ansible, right? So Ansible goes in and it configures the HTTP daemon. It copies files out of the source code repository, templates down the license, the configuration. It installs the application. It configures Nginx as a reverse proxy on the application. And so literally, starting with this main.yaml, you run this thing through Ansible, and you go from 0 to a deployed instance of high availability Artifactory with 3 servers, a storage account, a database. Everything's installed, running, licenses installed, certificates installed. You have a running instance in about 10 minutes with no user intervention. So that's sort of the big picture of where we're headed with it. And I think it must be close to the end now, right? Maybe time for a question or two.
Can you go back to the charts that have
Sure. I think I have to do this. This one? Yeah.
Can you talk a little bit about containers? MongoDB, what do you do with it?
So we're very early on our container journey. They're on the chart because we know we have to do them. They're a buzzword. They were at the Gartner conference last year.
You had to worry about patching your servers. You know, you have to patch all these machines.
We're using Azure Update Service for that. So everything gets deployed. As soon as it gets deployed, it gets put into an OMS resource group, an OMS workspace, and we automatically capture those new servers, add them to an update group, and start scheduling updates to them.
You've got your DR and your failover all set up.
I'd say we're about halfway there with DR and failure. One of the things is in the cloud, you got different strategies for DR and failover, but we're using ASR, we're using some availability sets, we're using, so there's different ways that we're doing the failover, right? But we've mostly we're there with that, yeah. Okay, thanks very much.